everyone, I'm Siddhartha. I'm a second year BTech IT student from NSCC, Kolkata. Now, welcome to our channel CodeChef. Today, we would be discussing the problem Mahasena, which has a problem code of AMR15A, and the difficulty level of this problem is easy and the prerequisite to this problem is none. Now, let us understand the problem statement. So, we are given an army and then we are told the number of weapons each soldier is holding, and he is considered lucky if he is holding even number of weapons and unlucky if he is holding odd number of weapons. So he considers the army ready for battle if the count of lucky soldiers is greater than the count of unlucky soldiers. Okay, else it is not ready. Okay, suppose the count of soldiers is 5. Okay, suppose there are 3 even numbers 2, 4 and 6 and 2 odd numbers 3 and 5 itself. Okay, so there are 3 lucky soldiers and 2 unlucky soldiers. So the army is ready for battle itself. Okay, so we are given the number of weapons each soldier is holding, and our task is to determine if the army formed by all these soldiers is ready for battle or not. Okay, now let us read the input and output. Okay, the first line of input consists of a single integer n which denotes the number of soldiers. Okay, suppose we are given 3 itself. Okay, and then the second line of input consists of n spaced integers a1, a2 and an. Okay, till an. So suppose we are given 1, 2 and 3. Okay, so how many odd are there and how many even are there? The odd count we would be representing with O. Odd count is 2 and even count is 1 itself. So odd is greater than 1. So the soldiers are not ready. So we would be printing not ready, else we would be printing ready for battle. Okay. Now let us move the sample test cases. Okay. So we would at first count the number of lucky soldiers and the count of unlucky soldiers. Okay, we would be representing odd with O and even with E itself. Okay, and we would implement in this way only. Okay, so this 11 is odd, so we would be incrementing its count. 12 is even, so we would be incrementing this count. 13 is odd. Okay, so we would be incrementing 1 to 2, and then 14 is even, so we would be incrementing this itself. So now we are told that if the even number of the lucky soldiers, okay, is greater than the odd holding weapons. So we are told that if the number of lucky soldiers are strictly greater than the number of unlucky soldiers, okay, so odd would be unlucky and this would be lucky itself. Okay, so it is not strictly greater, so we are printing not ready itself. Okay, now the first one is the even, so we would be incrementing its counter. Second is odd, so we would be incrementing this counter. Third is again even, so we would be incrementing this counter. Okay, so even ones are lucky. So now the number of lucky soldiers are strictly greater than the number of unlucky soldiers. So we are ready for the battle. So we are printing ready for the battle. Okay, now let's see how can we implement this. Okay, so we need to check if the number of lucky soldiers is strictly greater than the number of unlucky soldiers. Okay, so lucky is greater than unlucky. Okay, if this is true, then we are ready, else we are not ready. So who all are lucky? The number of even the number of soldiers who are holding even number of weapons is greater than the number of soldiers who are holding odd number of weapons itself. Okay. So now we need to count the number of soldiers who are lucky. How would we do? We would keep a counter variable. Okay. We would initialize with the number even with 0 and odd with 0 itself. Okay. Now what we would do is we would iterate on each element and check if it is divisible by 2 or not. Why would we do that? Because the numbers which are divisible by 2 are even numbers. Even numbers divisible by 2. On dividing by 2, the remainder would be 0 itself. Okay. So what we would be doing is, suppose it is AI. So we would be checking if the remainder on dividing with 2 is 0 or not. Divide it with 2, and if the remainder is 0, then it is even. Else it is odd. Okay. So if we want to do it in a kind of if else, we would do the same thing in the programming too. We would implement a if else statement. So we just need to write if and enclose this and do this and else do this. Okay, in the same way. Okay. After that, if the number of even is greater than this, we would be printing ready for battle. Else we would be printing not ready. Good to go. Now let us implement this. At first we would be taking the input of n. Then what we would be doing is we would be storing each of the input in an array. You can skip this part because storing won't help in the program itself. You can directly do that, or else you can store that too. Okay, so storing is a common practice, so we would be implementing in that kind only. So we would be making an array of size n, and then we would be doing a for loop int I is equals to 0, I is less than n, and I plus plus, and then we would be taking the input of the array, and then what we would be doing is we would be initializing a counter odd with 0 and even with 0, and then we would be again iterating on the array itself. Okay, I is less than n and I plus plus. If a dash I modulo 2 is equals to 0, then even would get incremented. If this is not the case, then odd would get incremented. Now, what is the functionality of the modulo operator? Modulo operator tells us the remainder. Okay, it would report the remainder to us. Okay, now let's move forward. Okay, now if the even ones are lucky, then we need to check. So if E is greater than odd, we would be printing ready for battle itself. Okay, ready for battle with an end line. Good to go. Else, if it is not that case, we would be printing not ready. Let us check on the sample input. Yeah, it is performing absolutely correct on the sample input. Okay, let us see each of the test cases. Yeah, it is performing absolutely correct. Now let us submit this. So at first we would be removing all the boilerplate code, and then we would be pasting our code, and then we would be submitting it. Okay, and the submission is queued, and we would wait for the verdict itself. And yes, we got an AC. If you are interested in competitive programming and want to learn and master data structures and algorithms, this is a one-stop destination for you. Every week, we post CodeChef problem explanation, live problem solving sessions, and frequently asked interview problems. Consider subscribing this channel if you haven't yet already.